screencast for the vector notebook homework problems. So I've got answers here. I did them out of order because I was an idiot and I was looking at number 3 before number 2. But I'm going to go through a little bit of these. Of the homework problems, 1, 2, 3, 4, 5, 6, I think 3 and 5 are challenging because you need to use a vector box. 6 and 7 are challenging because they're river problems. And notice I did give a hint on the homework about where you can go in the physics classroom for a whole bunch of river problems. So for number 1, oh, by the way, I have Teddy Heberly and Tyler Carter in my class because they're physicists extraordinaire. Say hi.
Hi.
Hey guys.
I, they can't, but it's okay. She waved, which is nice. So we've got a submarine which is diving 110 meters at a 10-degree angle. So we're finding the horizontal vertical components. So that's simply looking at this, the vertical component over 110 is equal to the sine of 10 degrees because that's opposite over hypotenuse. Adjacent over hypotenuse is cosine function, so we do a similar thing there. We get that it moved vertically down 19 meters and horizontally 108 meters. Skipping to number 2, this is looking at the resultant of a putt that went 6 meters east and 5.4 meters south. So the resultant I can get the magnitude by using Pythagorean theorem. The angle I can get using inverse tangent, 5.4 over 6. It gives me 42 degrees. So the way that I've got it drawn, it's 8.1 meters at 42 degrees south of east, or you could say 48 degrees east of south if you'd drawn it a little differently. For number 3, this one I think is the toughest one. So I've got 4 vectors and I need to find the resultant of all 4 of those. So I'm going to set up a box 1, 2, 3, and 4 where each vector has a north component and an east component. First vector is 100 east, none north. Second one is going south, so I'm going to call that negative 300 north and 0 east. The third one, I'm drawing another triangle over here to get the westward and southern components, and so those are both negative. So notice it's a negative 150 sine of 30 degrees for north, negative 150 cosine of 30 degrees for east. And then for the last one, I've got this triangle drawn. And to find the north part, I use 200 sine of 60 degrees because that's opposite over hypotenuse. And then for the west, it's 200 cosines 60 degrees negative because it's going west. So I add all the north parts up, I add all the east parts up, and then I redraw it. So it's going down or south 202 meters, to the west 130 meters. I get my resultant with Pythagorean theorem and inverse tangent. So that should be kind of a theme that you're seeing. So we get 240 meters at 33 degrees west of south. Number 4, you've got an airplane going to the east, and there's a tailwind also to the east. So since those are going the same direction, you just add them up algebraically, 165 plus 35. And if someone looked up from the ground, the plane would be going 200 kilometers per hour to the east. You may have noticed this before with slow-flying planes. If you look up and it's a windy day, they can either look like they're flying really fast or really slow if they're heading into the wind. For number 5, we've got 2 forces. It says that they're acting at a 35-degree angle from each other. And all we need to find is the magnitude of the resultant. So I set this up on an axis. It really doesn't matter how you do this as long as you're consistent. So I had 15 going east and 28 going at a 35-degree angle from that. And so I figured out the components of the one at a 35-degree angle, added it up to the 15 newtons east, got the total leg north, got the total leg east. Pythagorean theorem will give me the resultant. I don't know the real angle because I don't know where these were actually pointing, but I do know that the magnitude of the resultant would be equal to what I have there. For number 6, this is a vector problem where you're aiming due east, the current's carrying you south, and you want to find your resultant. So that's, again, Pythagorean theorem and inverse tangent to find that you're going 12.5 meters per second at 16 degrees downstream. To find the time to cross the river, you take the total width of the river, 1360 meters, divide by the horizontal speed, that's 12 meters per second, and you get 113 seconds. So horizontal distance goes with horizontal speed. To find the distance you're carried downstream, you realize that you're in the water for the amount of time you calculated in B. for every 1 second you're in the water, you're carried down a stream 3.5 meters. So 3.5 meters per second times 113-ish seconds gives me around 397 meters. The final problem I've got here, and I sort of scrunched this up unfortunately, the goal is to swim straight across the river. Therefore, the swimmer would have to aim upstream. So you put the swimmer's speed as the hypotenuse, aiming upstream. The current is heading downwards at 3.75 meters per second. Your resultant would therefore be due east in this case. So to find that angle, I need to use inverse sine because it's opposite over hypotenuse, not opposite over adjacent. And that ends up being 23 degrees. The resultant would be the hypotenuse squared minus 1 leg squared, the square root of all that, and that gives me 8.7 meters per second. So hopefully we get a chance to go over a few of these in class and any other ones. Again, hopefully you can look at this pencast or the screencast and figure it out.